So thanks everyone for joining. Thanks Trooper for having us here another year. Again, it's really a great conference, a great atmosphere, and especially having the SAP specific SAP track it's awesome to see so many talks and to be able to talk to so many speakers and have these experiences. So this talk is about SAP BusinessObjects. It's how many of you is familiar with BusinessObjects or is running BusinessObjects? Okay. Or maybe did an assessment to a BusinessObject implementation. Well, that's also valid here. So we're going to talk about different attacks or techniques that can be used by someone who has broken into an SAP BusinessObjects system, and then to understand the actual criticality of these kind of attacks. So yeah, disclaimer for you to read later, looking at the slides. So for those of you who are not familiar with Onapsis, with the company that we work for, it's a company specialized on SAP security, ERP security, but heavily focused on SAP. We are holding trainings, presentations. We report vulnerabilities also to SAP. So you will see credits for Onapsis also in the SAP security notes. We develop software and perform pen tests to SAP implementation. So those are the sources of information that we get, plus the research, in order to perform these kind of presentations and to hold these presentations on security conferences. Myself, my name is a Spanish name, so maybe it's JP is so much easier to remember. So JP, and Will, if you want to introduce yourself.
I'm Will Vandevanter. I'm a researcher at Onapsis Research Labs. And the presentation is part of a larger project we did on business objects. And we ended up submitting around 35 advisories, which doesn't sound that good in the statistics comparison. But we can't talk about any of them as part of the presentation, but we still work in the post-exploitation phases of it. So.
Thanks, Will. Yes, basically, Onapsis have been performing a research project. Is working with SAP in order to fix these vulnerabilities. We are going to be focusing mainly on the post-exploitation to understand the risk and to see the kind of information that can be gathered by an attacker from a BusinessObjects server. As a starting point, an attacker would be able to initially break into SAP system, this BusinessObjects system, by any of these vulnerabilities. Okay, so this is the agenda. We're going to do an introduction, talk about SAP BusinessObjects, introduce all of you who are not familiar with the product to the technology. Then we're going to talk about the attacker lifecycle, what's the profile of a potential attacker to an SAP BusinessObjects system, and other details. And then we're going to draw some conclusions that you should be aware of as SAP customers in order to secure the SAP BusinessObjects implementation. So, yeah, you're probably aware of this, right? If you're in the SAP track, all of you are familiar with the SAP systems. You know all this because you saw in previous presentations as well. And you know that business processes are being handled through these systems. But we are here not to discuss about SAP systems, but about SAP BusinessObjects systems. And what's SAP BusinessObjects? It's a product that was acquired by SAP in 2007 that's used mainly to perform business intelligence, to produce reports, to produce KPIs, key process indicators, dashboards, information that is usually not consumed by, and usually there are other exceptions, but usually not consumed by like regular people or regular employees, but usually for the upper management, right? So it's information that is used to take decisions and to act upon that. So that's why it is really critical, because you can, if an attacker is able to break into a BusinessObjects system and modify this information, he would be able to potentially modify the behavior of someone who is a decision maker. So yes, some other some other details. Usually it's receiving information. It's connected to the business suite, for example, like ERP, CRM, and all the rest of the products from the business suite, and it's receiving information from there. So it's not specifically processing business functions. It's not releasing a purchase order. It's not creating a new vendor, but it's receiving all the real information, like the production information, in order to consolidate this, process this information, and generate these reports and this deliverable that we have been talking about. So this is something that you saw and you will see many times, but it has a point to be here. Okay, so let me go to that point. So SAP systems, we all know that it's processing business information. We all understand the impact of a security breach. We can group that impact into espionage attacks, like gathering information, sabotage attacks, like stopping the system, stopping business processes, breaking interfaces, or even fraud attacks, like having financial information, bank account numbers, credit card information, modifying the salary, as we saw in another example. So that's pretty clear for everyone, right? But then when it comes to business objects, it is really a little bit more complex to understand the real impact of a breach into that kind of systems, right? Because per se, it's not processing business, it's not actually executing business processes, it's only holding information coming from the productive environment. So that's the criticality. And I'm going to show you some examples. For example, financial statement. A company who is in the stock market could every quarter or even yearly could generate a financial statement, a report of how the finance is doing, how the sales are doing, and a consolidated information that could be really useful for someone who wants to invest or even sell his stocks, right? So that's a real very visual example. But then you have decisions such as budgeting and staffing that are taken upon having these reports generated in business objects, sales forecast, liquidity planning. All this kind of information is being actually generated there and could potentially be modified, and the impact to the business could be really high. So it's not like a direct impact such as the one we usually talk about in SAP systems, but this is another type of impact because we can even get the information from the system, information that is coming from productive environments, and another option is to modify the behavior of the decision makers who are actually reading these reports. So it's all about business intelligence, right? So it's all about reports, it's all about indicators, and how is this actually happening? This is happening because there are some connections to the business object, and we have included this slide with some acronyms that are related actually, BO, BI, and BW. You know that SAP has a lot of acronyms that are changing in time, and products, new releases, new versions. But this conceptually, BO, business object, BI is the process of business intelligence, and business warehouse is the consolidation of all the business information. So what's the reason for having this here? Is because usually that's the most common scenario. A business object is not directly connected to the business suite, but to the business suite through a business warehouse system. The extraction from the business suite to a business warehouse is through ETL. That's a very technical concept. In the background is RFC calls. So somehow, for you to keep as information, somehow the information is flowing to a BW, and then the BO is actually consuming that information. So now Will is going to describe in details the architecture and some of the more technical parts.
So this is an architecture diagram from an older version, from BOXIR3. And we don't want to go over it. It would take forever. It would take too long. But it's really up there to kind of make a couple points. One is business objects isn't one application or one process. The default installation may have 20 processor executables running at once. And most of them aren't actually exposed to the users. So most of the blue boxes in the middle there are actually just processes communicating with each other. There's a pipe through the middle. And that's going to be the Corba service bus, which we'll talk about in a second. So that's a full diagram of it. I think this is a little bit easier way to break it down into 4 tiers. The top tier is the client tier, and so you have the top left there, that's a browser point, and that's typically where users are used to using business objects. They log into the app, maybe the CMC or one of the other business objects applications. Top right is going to be packaged applications, so this is something somebody downloads, they install it on their desktop, and it communicates with business objects. That feeds into the application tier, so this is basically where the client tier is translated into something that business objects can understand. That's either Java or .NET, and it would be the SDK also. So if a developer was developing apps, it would probably be within the application tier. In the gray at the bottom there, or in the middle I should say, is the infrastructure tier. So that was the majority of that map before, is the infrastructure tier. And each one of these cogs has their own job, and they typically have a listening network port or a listening port on the network. And they each have their own process or thing that they do, and they communicate with each other. At the bottom is the data tier, and so this is where you'll have usernames, password stores, the data that you're actually reporting on, or your connections to like the ERP systems. It can be relational databases, XML, text files. BusinessObjects actually supports a lot of background data tier. These services will come up a bit, so we put them on kind of one slide. The first one is the central management server, which is like the brain of BusinessObjects. It knows all the IPs, it knows all the ports. It's a very important sort of person in BusinessObjects. The second one is the file repository server. So as JP mentioned, one of the big points of BusinessObjects is creating reports. And so this would be where reports are outputted, or actually the templates where they come from. So it's a big part of sort of the context of the presentation, really. Server intelligence agent starts and stops processes. It's a small job, but it tends to have really high privilege, so it's an easy target, right? Because it has the privileges to start and stop processes. At the bottom here is the client endpoint. Again, this would be like the web app, so central management console is how you administer business objects. If you compromise that, you can create users, you can do anything you want to BO. Very bottom is web services. A little bit less important, but there were some good attacks a few years ago for web services. In terms of communication, there's really 2 major communication protocols BusinessObjects uses. One is HTTP, so most users are going to be familiar with that through the browser. SOAP on top of HTTP for web services. REST is available, and that's probably going to be more in the mobile space. But at the bottom here, we have Corba, and that's how a majority of those processes are communicating with each other, is through Corba. So it's very important to BusinessObjects itself. So Corba wasn't created by SAP. It was created by a group called the OMG, which was like a group of big companies that got together to define a standard that they needed at the time. It's really similar to Java RMI, so like if you look at a PCAP, it looks very similar. And it's because it falls under a distributed object paradigm. They're both distributed object paradigms along with SAP P4. And what that basically means is that you can invoke objects in another process or another system, which is kind of a cool concept, right? This is before web services. This is a long time ago, and so you would be able to create objects in other processes. So like, let's say I have a Hello World server, and I'd like you to be able to create a Hello World, or to be able to invoke a Hello World client. Basically, you would be allowed to do that through Corba. It uses the IOP network protocol, so Corba can be actually local, or it can be over TCP, at which point it uses IOP. It uses IDLs to define interfaces exposed. So this is like the description of the actual object itself. So to use a Hello World example, if I have my server and I'd like for you to be able to invoke it, I would give out my IDL and you would compile it with whatever language you like, so Java, Python, and you would actually get a version that could invoke that Hello World object. It's designed to facilitate with the communication systems on different platforms. So I could be Linux, you can be Windows, and we can work together. So it's pretty cool. It's a much older protocol. The second component, so besides the IDL, is the idea of an IOR. So an IOR is a reference to a remote object. So using the Hello World again, if I give out my IOR, then you actually know the IP, the port, and a reference to my specific object. So it's really the 2 things that you need to be able to invoke objects. The example components would be Like if I've given out an IOR and it's a string of hexadecimal characters, if you were to actually take it apart, you would see the object, so like hello, hello world, the host and the port, and not a token, but that is a token,
So
at the bottom there.
If you want to take a picture or something, you have to be very quick.
Oh, another chance, second chance. Okay, so that's the theory of it. In terms of how BusinessObjects actually uses it, each BO server has a number of Corba listeners, so probably in the neighborhood of 15 to 17 that can all speak Corba that you can invoke objects on, so it's pretty important. And again, there's two components. The IOR, so I would give away the IOR so that you could invoke the object, and then the IDL. And the IDL is a little more difficult because you either have to know the IDL or you can reverse engineer the IDL to actually invoke the object. Here's a quick example. So let's say you have a client, and if you have BusinessObjects in installation, you can use it, or you can try this out. Connect to the CMS, it defaults on port 6400, type in the string APS, and it'll kick back the IOR. The IOR is just going to look like IOR colon and a string of hexadecimal characters. And if you actually parse that, and there are online parsers you can use, or you can download a tool, you'll get the IP, the port, and you'll actually see the reference to the object called the object key. On the client side, you can actually take that and you can create objects from it, and you'll actually be able to control objects on the CMS.
Okay, thanks, Will. Yeah, basically those slides are introduction to understand the upcoming attacks and techniques that we're going to talk about. So, quick note on attackers. We said that this is not an ordinary SAP system. This is a system that is actually creating reports and consuming information. So yes, definitely you have the typical scenarios with internal or external attackers, advanced attackers or script kiddies, criminal organizations, but the primary attacker of this kind of solution or this kind of products are going to be either the internal attacker or potentially a competitor who wants to modify the behavior or get the information, right? There is no like actionable financial information per se, such as bank account numbers, credit cards information that can be easily extracted. Like the most direct profile for the attacker would be either the internal attacker or the competitor who's trying to get the information or modify the behavior again. So in order to identify this, you need to define monitoring processes, understanding this attack landscape, and define configuration and security standards. We will talk about mitigations, and we will talk about the guides that are provided by SAP also. So it's important to have that in mind in order to define procedures and security standards in order to have the BusinessObjects system secure. So yeah, we cannot skip to describe the ports that are listening by default. So by default you have the CMS, it's 6400. This is a port that is listening also Corba protocol, and it's the one that will tell you which are the dynamic ports as well. So this is like a primary port for the BusinessObject implementation. Then you have the server intelligence agent that will talk a little bit about this. This agent or this service can be used to start and stop the services. The CMS database, which could be SQL Server, MaxDB, Sybase, depending on the version, depending on your implementation, could change. Version management, this is interesting because BusinessObject is also shipped with something that allows you to do code versioning. So it's also interesting to understand that this port should not be exposed, for example, for end users. And then the web application framework, this is the most common port or the most well-known port, the 8080, because it's the one listening in Tomcat, and Tomcat is being used to expose BusinessObject applications. So Will held a presentation about this some time ago, mainly based on BusinessObject web interface. So that's just for you as a reference if you want to check. But this presentation is more focused on the internals on the protocols and the services of business object. So, besides those standard ports, which are more or less 5 or 6, there are other ports, each one per service. Those services that we'll describe very detailed. So there are close to 15, and these are dynamic. So in advance, you don't know which is the port assigned to each service. But there is a way to get this, because going through the 6400, you can basically query the ports for each service and get the information without the need of performing a scanning, TCP scanning. So for this, we have a demo.
So this comes from that the graph earlier, the client connecting to the CMS. This is just a recorded version of it. So again, you can telnet to the business objects CMS port, so 6400. Type in the characters APS, and it actually returned the IOR. So and again, this is what the IOR looks like: string of hexadecimal characters. So you can take that, and that will tell you the dynamic port from the CMS. It'll also give you the object again, and so now you can connect the CMS and say, give me all the other IORs. So this is a list of all services that are running as part of business objects. Or you could print it out as a list of IP and ports. And so the big point to sort of take away is attacker doesn't need to scan the network, right? They just ask the CMS, and the CMS will tell them everything they want to know, more or less. In the final piece here, we're using a tool called Cat IOR. It's part of the OmniOrb toolkit, which is a Python implementation of Corba. And it's actually parsing out the IOR.
Okay, yes. So as we described on the demo, we have 4 demos which are pre-recorded. We want to avoid the real life demo problem that usually happens. So even though you can have problems with videos as well, that it happened to us also, but we try to reduce the risk in this way. So what's the best recommendation in this sense? It's equivalent to SAP systems. SAP systems are shipped with a lot of standard ports in the ABAP stack, but mainly in the ABAP stack, also in the Java stack. Also, there are a lot of different ports included on each application server. So if for each one of the application servers, you will have new ports, different ports that should not be exposed to end users. So with this in mind, business objects should also be restricted. If there is no application connecting through Corba, those ports should never be exposed, only the web applications, and restricting which are the web applications that should be exposed to end users.
So again, this is following Reconnaissance attacker lifecycle. The next thing attacker may want to do is identify accounts. So there's a few different types of accounts in business objects. These are probably the 4 most common. The first is a required type of account, which is an enterprise account. So this is default to business. These are business objects only accounts. The next one is SAP ERP. So again, if it's hooked into another SAP system and the accounts are aliased, then the SAP accounts will be in there. Another reason to sort of put the slide on is if there are aliased accounts, then you take on any default accounts. So if there are default SAP ERP accounts, these may expose the business objects implementation. So it's an important point to make. Same things with LDAP and Windows AD. When we're pen testing, I'm sure any pen testers in the room, if you've included as part of it, there's almost always a default account. These are the accounts that come baked into the product. So the administrator account is, again, this is an enterprise account. It's the highest privileged account in business objects. It's in there by default, but it can be changed. It's actually kind of a cool feature. So you can actually change the name of the administrator account to take that risk away. SM admin is disabled by default. QAAWS servlet principal is actually enabled by default in BO4. And then the guest account. So the guest account is disabled, but it seems pretty common to actually enable it, which can be dangerous because there's some higher level privileges to the guest account than should probably be given to a guest account. BOE user and SA are specific database accounts. So BOE user is a suggested account, and then SA is going to be the hard-coded account, and this would be the default installation for Business Objects 4. Finally, at the bottom, LCM user. So JP mentioned there's an SVN server or LCM clear case that comes as part of the installation. The LCM user is the hard-coded username that's in there, and actually there's a support note for it, but the password's stored in clear text on the file system and in the web app, so it's important to apply that note. So again, I mean, these are obvious and they're in the administrator guide, but they're just so important. Applying the most up-to-date security notes. There's actually a vulnerability previously in web services where you could enumerate accounts. So again, there's a note for that now. Also, a cool feature is you can disable unused web apps or web services. And again, it's in the administrator guide. It walks you through how to actually disable accounts and lower the risk. So keeping up with Reconnaissance, version information is actually, it's a little hard to get. We can get major version information pretty easily. So through the web applications, like this is a screenshot from BI Launchpad. Before BO4, it was called InfoView. So an attacker can do a pretty basic attack to figure out what the major version is. There's also a web service, it's called getVersion, and it will return the version in its major and first minor. So it's not patch level, but it can get a little more granular than, say, looking at the web apps, but still useful. Finally, a warning about man-in-the-middle attacks. So all communication is unencrypted by default in BusinessObjects out of the box. And so the first inclination might be to lock down HTTP, which is important because the username and the password is passed, say, over to Tomcat. But a session can also be hijacked with Corba. So an attacker who can view any of those processes communicating with each other or any user coming in over the network via Corba can still hijack the account. And we actually show that a little bit later. In the administrator guide also, it's how to install SSL to Corba. So it's HTTP and then also Corba.
Yeah. Okay. Again, so this was like the first part, Reconnaissance, being able to identify the business object system, being able to understand what's the architecture, which are the protocols, which are the versions available, default users. So this is all the initial reconnaissance. But then if an attacker is able to exploit one of the vulnerabilities that is affecting the business object system, any of the vulnerabilities already identified or any zero-day or even a weak username with password, something like that, then let's say that the attacker would be able to compromise the business object system, right? So what we need to focus right now is on understanding the actual risk of this type of compromise. So there are two major potential issues with this, which are intercepting and poisoning. Okay, so basically you have the information there, you cannot modify the business information because business information and business processes are handled somewhere else, but you do have productive information there. So either you can modify the results or the reports or these indicators, or intercept the information if it's also useful. Well, if you're keeping up with the tokens, also another chance for you to take a picture. So, as I said before, which are the options that an attacker will face or would have if he has access to the business object system? Information disclosure of any information in the data sources, regardless of the reports and all these indicators, business objects are connected to other systems. Those business object products could be connected, as I said before, to BW or directly to an ERP, a CRM, a business suite system. We're going to see later an example of how an attacker would try to abuse of these pre-established connections, but just for you to know, the user configured for these connections needs to have access to that information, right? So at least the information that is being used to process and to analyze and to generate the reports is available for that attacker. And then, of course, the generated reports, we will see some examples also on how to access the reports, get the information, and even modify it. Information tampering, well, these kind of attacks could actually change. Some of these could be more difficult than others. Changing the data source system might seem as a pretty simple concept, but there are things that need to work, such as interfaces, users, RFC functions. So there are things that could make it more difficult, but conceptually the attacker could just change the system and point it to his own system and just generate completely different reports. Change the business data that is received through the wire, through RFC functions, and changes definitely on the generated reports. So in terms of information disclosure, well, we saw some examples like business reports, financial statements, and all this is possible because of these connections with these systems, CRM, ERP, HR module, SCM. So all these are examples of information. And then when it comes to information tampering, well, I think I went through the examples already. So changing info provider, info sets, changing the RFC function, the users, the system. So all these sort of changes would definitely affect on the resulting reports. So let's see a demo. Okay, so this is kind of a long demo. What we're trying to show here is the fact that from a compromise to a business object, the attacker would be able to jump to a different system. So the attacker discovered a business object system. It's on that IP address. He knows that URL, and he discovered the business object, executed an exploit, any exploit, 0-day, weak user, I don't know, any vulnerability that you can figure out could be executed, and the user has high privileges on the system. So once the attacker got access to the system, he authenticated into the CMC. This is the central management console. This is like a central administration application that is used by administrators to create users, grant permissions, and do all sorts of administrative activities. So the attacker is verifying that he has high privileges. He's part of the administrators group, so that's good for him. He starts looking on the different type of information that is available in the folders. He goes to the reports. Actually, that's a default folder, report samples. That's one like demo report that comes by default, so which is very nice. You will see all the financial information, the results of the company. So that's an example of a potentially valid report that can be accessed by the attacker. But then he also saw that there is another folder which is ERP connection reports. This is actually a set of reports generated through a valid connection to an ERP system. And you will be able to tell the difference between the ones provided by default and the ones that we created, which are very simple and not nice at all, but that's all the information summarized, processed through an RFC function that got configured through an info set, and that's it. The information is there, the report is there. He could get that and go home, but the attacker knows that if it was generated through a valid connection, then the information to connect to the source system is there. So it has to be somewhere. So he's going to the connections, and he sees that there is no information in the connections part. Okay. So he goes to, he heard somewhere that there is an application called, Query Builder that's actually used to create queries into the business objects in a language very similar to SQL, but very specific for business objects. So that's what he's accessing right now. He's accessing the Query Builder, and within that application he will try to execute some queries in order to get some interesting information. So the attacker already got those queries that he has in in the text file. So as you can see, the attacker is able to provide any query through that page. So for example, select SI seed, SI kind, SI name from info objects. Those are info objects are reports and informational, like folders, all these kind of generated documents. That information can be queried and the attributes can be retrieved remotely. But then, as you can see, financial, consolidated income statement, so all those are reports. But then not only the info objects source can be queried, also the system objects source. And that's a different information. That's more technical information. Users, all these groups, all this technical information. As you can see, the limit was reached. In the other one, it was close to 100, but now it went to a limit of 1,000 because there is a lot of information shipped by default after implementation, right? You have all this information on every business object implementation. But then there is another source, which is CI APP objects, and the attacker is actually accessing the APP objects where the kind is connection. And there are 9 results. All these are connections that are outgoing from the business objects to other systems. It could be a BW, an ERP, a CRM, whatever. For this case, this is an ERP. And then he just wants to see details on the connection that he saw previously through the CMC, right? He saw ERP connection, but through the CMC, no information is available. All the information is technical and can be queried through this interface. So once the attacker submits the query, he will get technical details about this connection. The first part actually is an XML equivalent, so it's information that is technical for the connection, but there's no IP, username, password, client, there's nothing there. Because all that information is here in the connection param strings, which is encrypted. But this can be also decrypted, and the attacker knows that, so he copies the contents of the SI connection param string, which he believes can be decrypted, and he has already a script to do that. So it's just copy the contents, go to the terminal. He's just browsing to see if he finds something else. Then go to the terminal. There is a script that is called decrypt SIS properties. If you provide any text, it will return like random text. But if you provide the previously encrypted text, the attacker would be able to get all the connection parameters, right? So using that information, the attacker would be able to connect to the source systems, which is actually critical depending on the privileges of this user. So if this is properly configured, the user credentials and the authorizations and everything that is configured here should be restricted to only access the specific information that is required and nothing more. So a support user there should be really, really critical, because that should imply a full compromise of the source system. Well, on this example, the administrator just configured, he had a last-minute requirement. He needed to set up the connection and create the reports, so he configured a high-privileged user, which is what the attacker is going to try. He's going to create a new connection in the SAP GUI tab, in the Logon tab. He configures the IP address, the system number, and he's going to try to connect through the SAP GUI to the source system. So all that information that he's providing there was retrieved from the decryption of the SI connect param string. He's connecting there, providing the username and password, and he's going to be able to log on, right? So in this example, this user has high privileges. it could be restricted depending on how the system was configured, because this is not something that is automatically configured. This is something that you need to set up. You need to create all the authorizations, assign the role and everything. So now the user is able to connect to the source system. Depending on the source system, if it's a BW, an ERP, a CRM, the criticality is going to be different. Sorry, this is the next demo. But it's still possible because the information is there. This is equivalent to the solution manager issue, that there are connections, outgoing connections to all the target systems. Well, if there are outgoing connections with username and password and there is no user interaction there, the credentials are there and the connection is possible. So this is
keeping with the compromise idea. So we can imagine how somebody has attacked a client at this point. So maybe pass the hash. Anyways, the attacker is actually going after somebody who has access to business objects. And so commonly, like when we would do pen tests, you'll look for a couple things, right? I mean, these are really obvious. You check the file system looking for file extensions. You want to pull a report off. Maybe check the browser cookies. But sort of how else can we go about doing that? One is network sniffing. So the attacker can network sniff. Again, active traffic is going to be best. They can see a session. Maybe they can hijack the session. But it turns out it's also possible with passive traffic in business objects. The client will actually auto-ping the server on a set schedule, and the core of the sessions are a lot longer than an HTTP session. So let's imagine a user is logged in using one of the thick clients. They walked away from their system, and they leave it overnight. Right? It's not being used, and so it's auto-pinging the server on a set schedule, and the session ID is actually given in the ping. Oops. There we go. OK, so attacker's taking a PCAP. They're actually looking at it through Wireshark. It's a little hard to tell here, but the Wireshark dissector for Corba is really good, or the filter. So we're filtering on GIOP traffic right now. In the bottom right there, you can see the ping request, and there's actual Corba session ID given within the ping request. So the attacker can copy it, take it over. And so at this point, this is Corba only, right? This is a Corba only session, but one of the Corba features of the services is you can actually ask for what's called a Logon token, which can then be used with the web application. So we have a script here. It's going to take that Corba session and actually turn that into a Logon token to access the web app. Logon token generated. And this is going to the CMS to ask for the Logon token, right? So it's taking that Corba session, going to the CMS, saying, let me have a web app session from that session that I just took. And so copy the Logon session or the Logon token into the browser and actually say view a report or log in as that user. So now the report's up there, and depending on which app it is, you could actually modify the report from here. So it could be actually to steal the report or to poison the data. So how else can an attacker do it? One way they could possibly do it is through PowerShell. So if BusinessObjects is installed on a client or a server, then PowerShell is made available to the user so that you get SDK-like functionality. It's pretty cool, actually. You get reporting access, info queries, session handling, and they can all automate the entire process. So if you imagine an attacker's tool set where they're using PowerShell to just automate BusinessObjects attacks. And if you're interested, if you Google PowerShell and BusinessObjects, there's some interesting scripts to check out. Next attack. So the attacker, let's say they decide to go after the server. Again, they're using pass the hash. They compromise the server. All they know is BusinessObjects is installed on there. So the file repository server actually turns out it's a part of the file system. So if you actually go into the file system for the server, you'll see the input and output file repository server. So all of the reports are going into there, and then the template reports also start out in there. To BusinessObjects, a report is a file in the file system. Then it's also an entry in the info store. So by overwriting the file in the file system, they could actually poison the reporting process. So a quick demo of this. Oh, there we go. So this is the report we start out with. And it's a really obviously happy report. You know, everything's good, green smiley faces. So the attackers now, they know where the file is in the file system, or they've looked it up. And this can be done, like if you go through the file system and if you look through the FRS, you can actually see all of the reports in there. It's very obvious. So the attacker deletes it on the file system, replaces it with their modified one, and then when somebody goes to view it through the web app, it'll actually be poisoned at this point. Because again, BusinessObjects is just thinking of that file on the file system. So go up, and then somebody logs in to actually view the report. They'll see the report is no longer happy. It's actually doom and gloom. It's a very sad report. And somebody's getting fired over the report. Oops. It's all you, bro.
Okay. Thank you. Okay, so some conclusions, and then we can go to questions. Read the admin guide. There is an administration guide provided by SAP that covers many of these issues, especially about network filtering, about management of the systems, about encryption. So all these already known concepts are also applying to the business object system, so should be implemented. So yeah, definitely many of these attacks can be prevented, but especially keep the systems updated. There are SAP is continuously releasing second Tuesday of every month SAP security notes. There are going to be SAP security notes for business objects in the following months probably, so I really encourage you to keep up with the patches and update the systems. Enable auditing. There are in the following talk, in the last talk of the day for the SAP security track, we're going to talk about anti-forensics. So we're going to provide some examples on auditing on business objects and some of its like weak points. But still, regardless of these weak points, you still need to enable it, because otherwise you don't know which user is performing which activities. Periodically scan and monitor the systems definitely, and secure the systems and the critical data. Don't forget that even though this is a BI system that is probably not covered by a standard or SOX or compliance policy, then you still need to secure the system, because otherwise there are different attacks that can be performed, like gathering information, tampering with the information, or even jumping to the source systems as well. So if you have any questions, now is the time. We can also go back to the slides if you want to take a picture of the tokens. Yeah.
When you went for the active connections, you said that they were encrypted, the connection parameters.
Yeah.
So which algorithm or how are they encrypted?
It's I think it's a SOR with a hard-coded key. The encryption algorithm is really not secure, but there are other encryptions on top of that. Like if you want to access it directly through the database, there is an encryption in the database, and then you have this other level of encryption. So here, if the user is able to access this through queries, he needs to have high privileges. But if the attacker is trying to access this through a database, there is a different level of encryption. So the SAP Business Objects, especially in the latest versions, is including FIPS compliant encryption and encryption in different parts, which is very good. But these kind of attacks are still possible because the information needs to be available for the system. So that's a problem. If there is no user interaction, then the system is going to decrypt somehow the information, and in that sense, an attacker will try to act as the system to access the information. Any other question? Okay, if you have any other questions later, you can reach us. We're going to be the whole conference here. So thanks a lot for joining this talk, and hope to see you later.